This is the 2015 MEXT Undergraduate Mathematics B. Section 1, Number 1. We are given this equation: log base 10 of ax times log base 10 of bx plus 1 equals 0, where a, b, and x are all positive numbers, and we have to find the range of b over a. So first of all, because b is positive and so is a positive number over another positive number must always be positive. So we know that b over a has to be a positive number. So let's write that down here. b over a must be greater than 0. And next, let's rewrite this equation. I just moved this term to the right hand side. So this equation is in the form m times n equals minus 1. This implies three possible cases. 1. M equals 1 and n equals minus 1, or m equals minus 1 and n equals 1, or m and n are negative reciprocals. By negative reciprocals, I mean numbers which are equal to minus 1 when they are multiplied. So let us first assume that the first part is equal to 1 and the second part is equal to minus 1. Recall that log base p of q equals 1 implies that p is equal to q, and log base p of q equals minus 1 implies that p is equal to 1 over q. Therefore, log base 10 of ax equals 1 implies that 10 equals ax, and log base 10 of bx equals minus 1 implies that 10 equals 1 over bx. Therefore, bx must be 1 over 10. b over a is equal to bx over ax. Therefore, when the first part is equal to 1 and the second part is equal to minus 1, b over a is 1 over 100. Likewise, when log base 10 of ax is minus 1 and log base 10 of bx is 1, ax is 1 over 10 and bx is 10. Therefore, b over a, which is equal to bx over ax, is 100. And now, let's consider the third case. M times n equals minus 1. For example, if we assume that log base 10 of ax is 2, log base 10 of bx must be negative 1 over 2. When log base 10 of ax is 2, ax must be 100, because 10 to the power of 2 is 100. When log base 10 of bx is negative 1 over 2, bx must be root 1 over 10, because 10 to the power of minus 1/2 is root 1 over 10. So I made this very simple table where you can see what happens to the value of b over a as the value of log base 10 of ax increases and decreases with respect to log base 10 of bx and ax and bx. If the vertical axis represents b over a and the horizontal axis represents log base 10 of ax, as we go from 0 to positive infinity, the graph reaches its maximum at 1, 1 over 100, and then it goes down and it approaches 0, but it never touches the horizontal axis. And starting from the point minus 1, 100, if we go right towards the vertical axis, the value will increase, and if we go to the left towards negative infinity, the value increases. Therefore, b over a is greater than 0, but it's less than or equal to 1 over 100. Or b over a is greater than or equal to 100. Question number 2. In order to solve this problem, there's one trig identity that you need to know. Cosine 2 theta equals cosine theta squared minus sine theta squared. So let's substitute these values into this formula. So cosine 2 theta is equal to root 2 over 2. To get the angle 2 theta, we need to find inverse cosine. And we are told that theta is between 0 and 2 pi, meaning that 2 theta is between 0 and 4 pi. And inverse cosine of root 2 over 2 is 45 degrees, but we know from the question that cosine theta is positive while sine theta is negative. So which quadrant are we in? A, S, T, C. We must be in the fourth quadrant because C means that cosine is positive while sine is negative. So to get this angle, we have to do 4 pi because we have 2 revolutions, minus pi over 4. So 15 over 4 pi. And this is the answer, 15 over 4 pi. Question 3. We are told that y equals log base 2 of x plus root x squared plus 1. And we are to find the value of 2 raised to the power of y minus 2 raised to the power of minus y. If a is raised to the power of log base a of b, then this is equal to b. Similarly, if a is raised to the power of minus log base a of b, this is equal to 1 over b. So let's substitute this value into y here, which is equal to x plus root x squared plus 1 minus 1 over x plus root x squared plus 1. And the rest is purely algebra. So the answer that we want is 2x. Question number 4. So we are given this awful looking function, which is basically a nested log function, and we need to find the domain of x. In order to solve this kind of questions, we need to use the following fact. Log base a of b implies that b must be a positive number. Therefore, what's inside log base 2 here, this must be a positive number. So we have the following inequality. Log base 3 of log base 2 of log base 3 of log base 2 of x. 3 pairs of parentheses. This expression must be greater than 0. And you need to know 2 specific tricks. 1. If a equals b, then c raised to the power of a equals c raised to the power of b. And the second trick, a raised to the power of log base a of b is equal to b. Actually, there's another trick, or another rule that you need to know. A constant raised to the power of 0 is 1, And if you know these rules, you should be able to solve this inequality. So let's have 3 as our base, and raise this number to the power of log base 3 of log base 2 of log base 3 of log base 2 of x. 1, 2, 3. And we do the same thing to the right hand side. 3 raised to the power of 0. According to the first rule here, this should be allowed. And according to the second rule, a raised to the power of log base a of b is b. Notice that we have 3 and 3 here. So these two are a in this rule, and this expression inside is b. So we can basically extract what's inside of log base 3. So now we have log base 2 of log base 3 of log base 2 of x, 1, 2. And any number raised to the power of 0 is 1. So 1. And we iterate this process over and over again until we have only x on the left hand side. Three times 3 is 9, and what is 2 raised to the 9th power? According to my calculator, 2 raised to the 9th power is 512. So there you go, we have the answer. X is greater than 512. Question 5. When I first tried to solve this question, I misunderstood or misinterpreted the question. My initial understanding was that there was a 5-digit number, and we have to subtract a 4-digit number an n number of times until the difference becomes 1, 1, 1, 1, 1. But this apparently is not the correct interpretation of this question. The correct interpretation, there's a 5-digit number, and we are subtracting a 4-digit number just once, and the difference has to be 1, 1, 1, 1, 1. So what are the combinations of two numbers whose difference is 1? 9 minus 8. But because we are subtracting a 4-digit number from a 5-digit number, the first digit of the 5-digit number must be 1, because we are not subtracting any number from 1. So this means that we cannot use this pair. So this implies that the number 2 is one of the 4 digits on the bottom, because if it were on the top like this, then we would have to use 1 here, meaning that this pair has to be used, and that excludes the next pair. So we are only using these pairs. So one example would be this. So what this question really means is to find how many ways these 4 pairs of numbers can be arranged. So that can only mean 4 factorial, which is 4 times 3 times 2 times 1. So the answer is 24. Section 2. So the question says that we basically have a circle and we are putting dots on the circumference, and then we are drawing chords between these points. If n is the number of dots, c sub n is the number of chords, I sub n is the number of intersections, r sub n is the number of regions. When n is 1, there is 1 dot on the circumference of the circle. So how many chords can you draw with just 1 point? None. When n is 1, we cannot draw any chords, and without any chords, there are no intersections. We have just 1 region here inside the circle. The number of regions is 1. When n is 2, we can put 2 dots on the circumference. How many chords can we draw? 1. When n is 2, we can draw one chord, and with one chord there is no intersection, 0. And how many regions do we have? 1, 2. So 2. N is 3, we can put 3 dots on the circumference. And how many chords can we draw? 1, 2, 3. N is 3, 3 chords. And how many intersections do we have? None. And how many regions do we have? 1, 2, 3, 4. N equals 4. 1, 2, 3, 4 dots. 1, 2, 3, 4, and 5, 6. When n is 4, we can draw 6 chords. And how many intersections do we have? 1. So 1 intersection. And how many regions do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 regions. When n is 5, 1, 2, 3, 4, 5.
1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
16. N equals 6 is going to be a little messy, but we should be able to do it.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31.
So this was the brute force method. But let's try to be a little bit more sophisticated. When we are drawing chords, we need at least 2 points. We are essentially choosing 2 out of n. Now the question clarifies for us that m choose k is 0 if m is less than k. So in the first case, n choose 2, 1 is less than 2, so this is 0. N choose r is n factorial over r factorial n minus r factorial. So 2 factorial over 2 factorial times 2 minus 2 is 0, so we can ignore that. 2 factorial over 2 factorial is 1. 3 choose 2 is 3, and so on. So the general term for C sub n is n choose 2, which can be written like this. And how about intersections? In order for an intersection to exist, there have to be at least 2 chords, meaning that there have to be at least 4 points. Therefore, we are doing n choose 4. 1 choose 4 is 0 because 1 is less than 4. 2 choose 4 is 0 because 2 is less than 4. 3 choose 4 is 0, and 4 choose 4 is 1. And 5 choose 4 is 5 factorial over 4 factorial times 1 factorial, which is 5, and so on. So the general term for I sub n is n choose 4, which can also be written as n4. And how about the number of regions? From this table, I hope you can see the pattern that exists between C, I, and R. Basically, 0 plus 0 plus 1 is 1. 1 plus 0 plus 1 is 2. 3 plus 0 plus 1 is 4. 6 plus 1 plus 1 is 8. 10 plus 5 plus 1 is 16. 15 plus 15 plus 1 is 31. So, R sub n is C sub n plus I sub n plus 1, n2 plus n4 plus 1. Section 3, which is the final section of this exam paper. So we have a cubic function named c, x cubed minus 4x squared plus ax plus b. And the first question says, when c is tangent to the x-axis at x equals 3, what are a and b? So a cubic function looks like this, and it says that at x equals 3, the curve is tangent to the x-axis like this, 3, 0. And because the x-axis is a straight line with a slope of 0, at x equals 3, this curve satisfies the following condition. F dash of x, which is the derivative of the function, this must be equal to 0. Let's first of all find f dash of x by differentiating this function. Dash of x is 3x squared minus 8x plus a. Let's find f dash of 3 equals 0, and let's solve for a. 3 times 3 squared minus 8 times 3 plus a is 0. 27 minus 24 plus a is 0. So a must be minus 3. And we know the coordinates of this point, 3, 0, which we can substitute into this function. 3 cubed minus 4 times 3 squared minus 3 times 3 plus b, and then solve this equation for b. b is 18. Question 2 says, when 1 holds, find all x such that c has points in common with the x-axis. So what this means is that we need to find the other roots here. From part 1, we know that one of the roots is x equals 3. So what we need to do is to divide this cubic function by x minus 3, because x minus 3 must be a factor if x equals 3 is a root. So let's do some division. X squared times x is x cubed. X squared times minus 3 3x squared. X cubed minus x cubed is 0. Minus 4x squared minus 3x squared minus x squared. Minus x times x is minus x squared. Minus x times minus 3 is plus 3x. Minus x squared minus x squared is 0. Minus 3x minus plus 3x is minus 6x. Minus 6 times x is minus 6x. Minus 6 times minus 3 is plus 18. And done. So this function divided by x minus 3 is x squared minus x minus 6. F of x is x minus 3 times x squared minus x minus 6. So next we need to factorize this part. Minus 3 times plus 2 is minus 6, and minus 3 plus 2 is minus 1. So therefore f of x is x minus 3 squared times x plus 2. So the other root must be minus 2, 0. Number 3, which is the final question, when 1 holds, calculate the area S of the limited region bounded by C and the x-axis. By limited region, I think it means this region here, between minus 2 and 3, f of x dx. This is going to be a very tedious calculation, so I'm just going to give you the answer. 625 over 12. And this is the end of this exam paper. Thank you for watching and see you next time.